Hello and welcome to Chapter 10, Calculating Ka from percent ionization. This is going to be a really short video, especially because this is the third time I've done it because my mic has been causing me problems. Alright, so in a 0.100 molarity acetic acid solution, we know that 8.1% dissociated. Calculate Ka. So luckily these problems are pretty straightforward. We start off the same way. Identify our major species, which in this case is acetic acid, which you're going to have to make sure you can memorize is CH3COOH, which is it strong or weak? This one is weak. Step 2, as always, write out the reaction. So for this, is this going to have a double-sided arrow or a one-sided arrow? Since it's weak, double-sided arrow. Okay, there's that. Now that I've written out my reaction, as usual, I will write out the equilibrium expression. So I know since it's an acid, my K is going to have a little tiny A next to it, not a B, it's not a base. Products over reactants. And the goal is to figure out what the heck Ka is equal to, so I don't know it yet. In order to figure it out, I need to know all of my different concentrations. And how do I figure out concentrations for something that goes to equilibrium? You probably guessed it. Set up an ice chart. Do I need to do a dilution for this problem? The answer is no, because it is not diluted. We don't mix it with anything. It's just acetic acid. ICE. Okay, I know my initial concentration of acetic acid. I know that at the very beginning I don't have any of its ions. And since I don't know final concentrations, I'll assume my X's. So this is all the usual stuff. Nothing new right now. Okay, so now we're going to have a new step. Because usually we would use the equilibrium constant to figure out what X is equal to, but we can't do that this time. This time we're going to use percent ionization to calculate X. Oh, my cat's sitting next to me. Hi, Sonic. Okay, so I know that percent ionization is equal to the concentration of the ion that we're interested in over the initial concentration. Times 100, because it's a percent. Okay, so in this case our ion concentration is represented by X. Both of these are the same, so we could say, it's just X. And I know my percent ionization is given to me as 8.1%. And my initial concentration of acetic acid, the original compound, is 0.100. So I end up with X is equal to 0.0081 molarity. I can use that to get all of my different concentrations that I can then plug into my Ka. So I know X is equal to H, which is 0.0081. I know that CH3COO minus is also equal to X, so 0.0081. Just narrowly escaped getting bitten by my cat. Acetic acid is equal to 0.100 minus X, which will give me 0.0919. So I'll move on to my last step, which is to actually plug these into my equilibrium expression. So I know that Ka is equal to the hydrogen ion concentration times CH3. Okay, that concentration over my acetic acid concentration. So in order to save space, I'll write it across. So in the very end, I'll end up with my Ka, 7.1 times 10 to the negative 4. And we are done.